parts that our team had to work on involved manufacturing. There were a lot of missing parts that we had to replace. A lot of parts had to be modified. There were parts that were made by previous years that also needed to be modified. Something went wrong in their process. And because of that, a lot of the parts we made needed to maintain visual authenticity. And to do that, for one of the pieces, we used this R-axis to CNC equipment to make this part here, which is the crosshead cover, make it look like the original. And because we had to keep that authenticity, we also worked with multiple kinds of materials. We worked with steel, cast iron, and brass. And working with brass, where it's a really soft material, it came with its own challenges. One of the other challenges that we had to overcome was the designing and manufacturing of the gaskets. We used a laser engraver to etch out on the gasket material these gaskets here, and also the gaskets that went on the cylinder covers behind those parts there. One of the things that we also had to do for manufacturing was making springs for our valve assembly. Some of those had gone missing, and that was something that none of us had done before. So we had to run calculations and make sure we had the springs what they needed to be. One of the other challenges that we had especially was with the piston rod assembly, where you can't really see it in this picture with this castle nut on the end of the piston rod. And we had to get down past the piston head to drill a hole for a cotter pin, and we had to make our own fixturing and all that for that.
Very good. Okay, here's the connecting rod, and it's all of its components. You have a couple bushings here that go around the pins that rotate inside the bushings, and this give and give key go down through the connecting rod and this yoke type piece, and it actually, as you drive the key down, it pushes the yoke onto the connecting rod and tightens up on the bushings here. And this is the crosshead that connects to this end of the connecting rod. And here's a picture of the whole assembly all together with the connecting rod and everything in place. And this is the crosshead down here. So this is the Stevenson linkage. This is a reasonably accurate representation of what we have, but this is a simplified version just to make it a little easier to explain, but it's still accurate. It works the same way. So we have the two different eccentric rods here, and they're out of phase with each other, so they kind of follow each other a little bit as they go around. And they're connected on this end through this half-moon piece here. And this is, the location of this half-moon piece is controlled through this lever in the cab. And so this 90-degree piece here, when you pull back on the lever, this rotates up, and it'll pull up this half-moon piece, which then acts onto the valve stem here. So when it's in this position, maybe forwards, the eccentric rod here has all of the action going straight to, all the action from this one is going straight to the valve stem. When you pull it up the other way, it goes into reverse, and this eccentric rod has all the action. And if you leave it in the middle, this kind of pivots back and forth, and the valve stem doesn't really have much action at all.
All right, so real quick, we did a lot of benchmarking on this project. One of the primary things we had to do, that included taking pictures of stuff, looking at how things fit, checking out primarily lubrication systems, clearances. Pretty much everything that we did, we had to look at how somebody else had done it because we didn't have any other way to follow it.
Right, the engines posed a lot of challenges for our group. There were parts that needed manufacturing, and because of either wear or non-standard parts and fitment and parts that had been manufactured previous to our group taking this on, there were a lot of assumptions that needed to be checked, and lots of asymmetry in bolt patterns, and we had non-standard thread sizes, piston rods manufactured by two different groups that weren't quite the same. So a lot of work went into working out fits and alignments for our parts. We also had to torque the pistons down onto the rods, and that was one of the first big tasks we took on. And after that, we developed a procedure for centering the pistons in the cylinders so that they had equal travel fore and aft. And once that was accomplished, then we could adjust the valves to suit the position of the pistons.
All right, and some of the things that we're looking towards doing next semester, a little bit listed out here. Under problem solving, we noticed that as a team, and we're all separated in different classes, getting pulled different directions, our communication and problem solving together is kind of hard for us all to collaborate. So we're looking into some software that we're going to give you guys some feedback on later that helps people who are more separate, all different directions, to collaborate a little better. Like found a good program for that. As far as continual improvement, we look for a couple of different things. We're looking into safety problems, maybe trying to get the word out more even than it already is. I mean, a lot of people know about it pretty well, but maybe trying to push more. And also maybe things easier for maintenance. So some of the stuff that we were looking at was maybe making a guard for the big steering gear up front. If it's going to be in a museum and kids are around it, someone could easily get pinched or caught in some of the movement up front. For our social media, we were thinking of maybe we could have a big Facebook page to help promote it a little bit more, because a lot of younger crowds get access to that better. And then two things for maintenance, we're doing a jig for positioning pistons for TDC, because we did a lot of painstaking things, and a mechanism for making the crankshaft easier to move, which is 1 or 2 people instead of 4. And then the last thing was, after the insulation and other stuff is packed away, we can finally install our steam chest and cylinder covers. We still need to retrieve one of the steam chest covers from Peter Grant, but other than that, we pretty much have everything good to go.
Excellent. Thank you, sir. All right, real quick. Some of the things we're going to be looking at going forward are safety and human factors. We have some controls in the cab that we need to look at. And also we're going to be looking at design challenges of the whole lubrication system, cylinder cock linkages, and then kind of redoing some stuff on our connecting rod. And that's where we're headed next semester.
Last month we were able to restore the smokestack by grinding down the inner and outer surfaces and painting it a matte black with heat-resistant paint. Afterward, we mounted it to the boiler, as you can see here, with 1/2-inch bolts.
Another thing we worked on is this steam door ring, which holds the steam door on. And we've had some issues with this because it is not an original piece. It was cast from the original, which was broken, and the pattern for that wasn't perfectly level on the bottom. And the end of the boiler itself is pretty flat, so there's a gap there. Another issue with it is the bolts that were drilled in it. The bolt holes that are drilled in it is a smaller radius than what the original was and what we would like it to be. So we compensated for that with machining spacers from the MTL to bring down the radius of the bolt pattern so that it would fit. That was donated from the MTL. And we put the steam door on, which is pretty straightforward. That fits pretty well. We're going to use some packing to seal it. And what holds the door shut is steam door buttons, which mount on these square parts. And we started machining those in the MTL using CNC. And then we found out that we could cast them, which would be more authentic out of cast iron. So we're going to do that instead.
We were also able to have a brass medallion cast for us by Peter Grant, as you can see in the center of the steam door. Originally, we had been intending to make it out of cast iron, but while making the bell cranks, we ran out of cast iron. So brass was the other alternative. But in the future, we do plan on having it made out of cast iron, so
Alright, I'm going to start off talking a little bit about the shaker grates for the boiler. For those of you who don't know, there's rocking grates in the bed of the boiler, and these rock back and forth and allow ash to sift down into a catch pan below. And there's a handle in the cab that you work back and forth to shake the grates. So this was actually the first project that our team tackled to put all this together. We had one linkage missing, and Spencer and I made that over in Crosby Lab out of a piece of scrap steel that we found. And this was the first system where we had an opportunity to use standard parts on the machine, and we used standard size cap screws, and in the future we'd really like to buy some square head cap screws in order to maintain a better sense of authenticity. And quick price estimation figures about $25 worth of parts. And Matt's going to talk to you a little bit about some of the struggles we faced on this project.
Yeah, so we faced a few problems during the course of the project, primarily three, and they consist of one of the issues we had with the shaker grates is that originally they had threaded holes, but these are the original shaker grates, so they're pretty worn out. So we ended up just bolting through the holes and making them effectively clearance holes. And yeah, I mean that's been our way of going about that. And it's worked out pretty well. The other is there's been interference with the shakers in terms of they collided at one point, and so we just got Mikey to get in there and grind the tips of the shaker grate fingers so they don't collide, and there's a lot more movement now. And the only other thing that we need is that we're going to work on next semester is getting the correct handle for the shaker grates, because we have a handle now, but we don't think it's the original. And so yeah, we're either going to manufacture that or see if we can find one in the shop. But yeah.
So one of the major pieces that we need to manufacture is the ash pan for it. We started off the semester by making a cardboard mock-up of it based off of Bill Lynch's scale drawings. It turns out that parts of that are not necessarily lining up with the underneath of the Lombard, so we've modified the design of it. The second part of that is soliciting a donation for the steel itself. And we've been in contact with Lane Supply and Bangor Steel. Peter and I actually made a trip down there. Unfortunately, that week it seems everybody was on vacation. So we've been in contact with Bangor Steel some more, and I admit I've been dragging my feet a little bit on that. But in any event, we do have another place that's willing to sell us the steel at cost for about $100 and vend it for free. So if we don't get the steel by Christmas or by winter break, I believe we're just going to buy it and have it done in that manner. And next thing that we need to manufacture was a bell crank for the damper door system, and Peter Grant of Odd Duck Foundry was more than happy to make that for us. He had a pattern already ready to go, and when we made it, we actually quenched it a little bit early, and so it hardened way more than we would have liked it to, and that's where I'll hand it off to Spencer.
Not knowing that it was hard, my first attempt was I stuck it on the drill press and destroyed one high-speed steel bit, thinking that the bit was dull. I tried again and toasted another bit. So, after finding out that it was quenched, I talked to Joel and we brought it to the machine tool lab and crawled through it with a carbide end mill at extremely slow speeds. It took about 3 hours to drill those 4 holes there, because we were turning about 60 RPM and feeding 10,000s per revolution. So just a crawl of the speed. So now that we know how hard it was, we did a hardness test and it was 41.7 Rockwell C. We're gonna stick it in an oven at roughly 1500 degrees and then just turn it on and let it cool slowly, and that should get it back to a temper that is a lot more appropriate for the Lombard.
So I'm going to talk about the ash pan that we still need to make in the links. So this is a photo from the Clark machine in New Hampshire, and you can see the bell crank. This is the handle that Matt was talking about that we need to make. And then there's some links that run down. This is a short one, and then there's a long one, which you can see in this photo runs the length of the ash pan. We still have to machine both of these. And we have we don't have these links, we have something else that was on there, but they don't come off at this angle, so we think we may have to make these as well. So we're gonna plan on trying to get those done the first half of this next semester. It shouldn't be too complicated. The other big project is this ash pan Raleigh talked about. We're trying to get the donations for it right now. We have a place that's willing to bend it. The hardest thing is going to be attaching it underneath the machine when we get it made. We're going to benchmark off the Crooker machine, but on the Crooker machine they had several attachments along the top here, and they had done just bolts with nuts on the inside. I don't know how they got in there with a nut, but they did somehow. We're planning on welding like probably 1/4-inch plate on the back and then drilling through it and tapping it and using bolts to go through and attach it to under side of the machine. And then the other problem would be where it attaches to these damper door openings along here and along here. On the Crooker machine it's riveted. I think we decided we don't want to rivet it in case we want to be able to take these things apart. But you could still rivet it and take it apart. We're going to try to do, I think, bolts. We're not 100% sure, but okay. And we'll go to Jeff. He's got the next stuff.
All right. So as Greg mentioned before, there is up to a 1/4-inch gap around the boiler. Next semester, or hopefully maybe over break sometime, we're going to actually grind the boiler so that the steam ring fits, and we're going to try and get it as close as possible. And if it doesn't fit exactly, we might use a hard gasket to put in between it so it seals perfectly. And also, as Spencer mentioned, we need to put the bell crank in the furnace. We've been in contact with Professor Karen Horton about using her furnace and put it in there, but she requires we find the carbon content of it first. So we have to test it to figure out the carbon content before we can actually put it in the furnace. And also the clean out and inspection door rings. Peter Grant actually has these pretty much molded up. We just have to, or he has the mold for it, we need to actually mold them and make them and get them from him. And then we can drill the holes in the actual boiler once the steam team, or the, yeah. And that's it.
So a quick overview, our team had many different projects, so we broke up into small groups. We focused on the differential cover, assembling and installing that, lubricating the entire track and bearing lubrication system, as well as installing the bearing covers, top and bottom. We also installed the drive chains and wrote a procedure for that, and we also worked on machinery haul. We'll talk a little bit more about each of these things.
Okay, so I was partially responsible for the differential cover. When we first started this project, we found that we had a non-original differential cover installed in the machine, and within the first few measurements we took, we noticed that it was very crooked. I don't know if it was a welding issue or a metal cutting issue, but we basically had to make this work. It wouldn't be cost effective to make a new one, or time effective as well. So we took the differential cover off and determined that we needed new bolts to assemble it. So we went to Fastenal and got new bolts. And once we got this assembled on the machine, we were able to check clearance to figure out how we could actually mount this to the frame of the Lombard. We determined we had about 1/2 inch of clearance on each side, and we're able to weld in 3/8 plates on the inside of the differential case, and then we drilled and tapped those to mount the case to the frame of the Lombard.
So I was responsible, or the other person responsible for the differential cover. One of my big roles was getting this assembly done. That took some time where we didn't want to just take it off Bill's old drawings, so we had to measure everything and get our own assembly drawing. Still, it's half decent, so that's good. Another thing that we had issues with, it was too wide this way, and we had issues mounting it to the actual machine. So we had to machine pockets in the existing brackets, and that made it able to be mounted. And I wish I had a decent picture to show how we had done that, but in our logbook we show the pockets that we machined out.
Alright, so I'm going to talk about the Lube System, and this is something that Brian and I teamed up to accomplish. And originally there was 6 lube screws that were approximately 1 3/8 in diameter for the top bearing covers. And then there's 2 on the top and then 4 on the bottom to lubricate the bottom, basically like the drive shaft, connected to the differential. And 2 of those were missing, so we needed to machine 2 of those, which we used. We were able to get a donation from Fastenal to get some threaded rod to make that, and Brian will talk about that in a little bit. We converted to Zerk fittings on the track. The runner casting, it was originally like a loop screw design, like the Piece 210 loop screws there. So we converted over to a Zerk fitting design. We designed caps to go over the Zerk fittings to keep it looking authentic. And we also designed covers to go over the back of the lube cavities in the track, and we'll talk about that in a second.
So here's just a comparison of the original compared to the remanufactured ones. And as you can see, we tried to use a dividing head to get the square head, like the original would be on the top of that lube screw. And we also, those nuts were actually twice as thick, and we decided to cut them in half to make it look more original. And I think we did a pretty good job accomplishing that, and it functions perfectly.
So here you can see our Zerk fitting conversion that we did. And there's 4 of the Zerk fittings on each side of the machine. And it allowed us to not have to modify the threads in the track, runner casting. And it also allowed the customers to be able to lube the machine without a mess, and also as far as time, it's a lot quicker and easier to lube the track. Just uses a traditional grease gun. And here you can see we designed a cap to go over the Zerk fitting. This is the Zerk fitting here, and then this is the cap that would go over. And it utilizes the threaded rod that we got donated from Fastenal. So this is a thread here with a square head machined onto it, and it's secured with a set screw that'll be hidden on the back. We're going to machine that next semester and keep it most authentic.
And currently I'm handling the rear drive axle lube chamber covers, which are not, they don't appear to be original, so it's kind of hard finding a design for it. So I designed a part that would look as a one-piece cast, but actually the hinge and the cover part would be welded together, grinded down and painted, so it wouldn't have any bolts in it, because that wouldn't be as authentic. And there are some issues with designing this because there are 4 covers that need to be made, and they're not all alike. So I had to design one cover that would accomplish, it would successfully fit on all of them. And this is what I propose to do, and will probably require a little bit of tweaking, but I think it would accomplish successfully.
The major project I worked on this semester was the bearings. I'm sure you guys saw me elbows deep in lithium grease at some point this semester. The first thing we noticed with the bearing covers, there's 2 that go on the top of the shaft, and then there's 4 that go on the bottom of the bottom shaft. The top 2 do not appear to be the same. I believe that one of them is from a different Lombard machine, but we assembled them and we got them greased up and they ran fine when we did our test run. But there was some interference that we noticed, so we thought a shim was the proper fix for that. It turned out the shim was not the issue. We actually found out yesterday that the tolerance between the bearing and the shaft was a little too close. So that's going to be a major project that we start next semester off with.
Randy and I were tasked with coming up with an efficient procedure for putting both sides of the drive chains on. Fortunately, last seniors that worked on the Lombard created and designed 4 sections of chain for the drive chains, 2 sections per each side. The first time that we put them on, we realized that they were too long, so we had to press fit out 1 link from each side, which seemed to be a chore and a half. We also machined down a master point for each side of the chain so that each time you have to take them off, you don't have to press fit them off, which is good. Randy's going to talk about what else we have to do with the drive chains.
Real quick, because we're over time apparently, the drive chains, even though we took a link out, are still too loose and we need to adjust the track, which is going to be quite the process, and we're not 100% sure it's going to be easy to do because there's a lot of bolts to loosen, then you have to adjust 4 different screws on each side to adjust the track, and they all got to be adjusted evenly, so that's that.
And then here's us working on machinery hall. And our major things for next semester is machining the cap screws, the covers for the rear lube screws, painting the differential cover, and we will also be finishing the tolerance on the bearing covers. So, thank you.
Alright, so we're the boiler steam team. Had plenty of accomplishments, and we have a lot of things to work on for our next semester. John can start us off.
Alright, so one of the big things we had this semester was the Lube System. It was a big question mark at the beginning of the year. We were actually missing a box of parts. We knew they existed, but we didn't know where they were because Herb had taken a photograph of them last spring, but we couldn't find them anywhere. And they were in that back room in the other shed, like right on the desk in the middle, and we were digging and digging, and they were right in front of our face the whole time. So we found those parts, and in that was that winker, which is this piece right here, which basically shows whether or not oil is flowing. And that, we had to take all apart and clean it all out. We replaced the gaskets in it. And then we had to take the whole top part of that, which is the pump, and the bottom part is just a reservoir, which was missing the sight glass because it was broken off, and all the gaskets that went with it. So we put all new gaskets in, took a wire brush and power drill and cleaned all the oil reservoir stuff out, and then we ended up having to wipe it out, oil it up, wipe it out, oil it up, wipe it out. But then we were able to pretty much get that to where it would pump oil, which was a big success, although if you've seen the video, it's not all that exciting. Then we had to work on the actual linkage that drives the oil pump, and we had Don Stedman made the doohickey. It's just a connection. It's got 2 axes that it swivels on that connects the rod from the ratcheting oil pump down to the bell crank. We had to replace the bell crank because that was broken. We built that twice now. We built it once and we thought we had it, and that was because the Stevenson linkage wasn't installed, and then when they installed it, we noticed it was hitting. So we adjusted it again, and we've almost got it right, but we're actually just going to change the angle. Right now it's set on 90, and we're going to change it so it's more like 120, so we'll have more clearance, but the oil pump will still function.
Next, we had to work with an air system, and we needed an air system to test the machine for our Thanksgiving Day deadline. And we benchmarked the Crooker machine, which they pressurized their boiler and then used their existing steam connections to run the engines. And when we looked at the boiler code, we weren't qualified to pipe the system, so we had to come up with our own air system. And we came up with we actually used hydraulic hose because we could source that easily. We got a generous donation. And we used 3/4 inch hose from our throttle assembly, which is on the right. and we teed that off to each engine with a ball valve, so we could run each engine one at a time if we wanted to. And then the throttle unit consisted of the compressor fitting, and then it went to a emergency ball valve. And then after that was the regulator, so we could set the pressure to what we wanted, because the compressor was running at 110 psi and we wanted to dial it down, because this is our first time running it ever. And then after that was the lubricator, because we had to lubricate the air so we didn't ruin the engines. And then was our final valve, which was a butterfly valve, which was our throttle mechanism, so we could meter the air into the engines. And then upon test day, our unit worked, it functioned correctly, but there wasn't enough volume. We didn't have enough capacity to keep up with the large volume of the engines. So we installed an air tank, which we put before the whole system to store some air. And once we installed that, the engines ran for about 10 seconds. And so pretty much if we had a larger tank, we could run the Lombard longer. And in the future, we plan to use the boiler just like the Perkers do, because it's a large tank. But we have to wait until we have the steam piped up.
I'm going to talk to you guys about the steam system. Basically, we started off, we didn't realize how much of a challenge it was going to be to get this thing piped. Once we found out that we had to have a certified, ASME certified shop pipe it, we realized it was going to be very expensive. We basically have all the old parts that were originally on the boiler, as you can see in these pictures. As of right now, we're in contact with a couple companies trying to figure out where we can get some new injectors, and if they're going to work, and if the state boiler inspector is going to say that they're safe enough to use, as well as the tricocks, which are right there on the table. Those basically, you crack those open to see like what the water level is in the boiler. We found a website which has those pretty much identical to what we need. We're just waiting to hear back from Jake Olson from Sullivan & Merritt to figure out if the material is traceable and safe enough to use. The other parts of the system, like the sight glass, we have another place that we're looking right now. Actually going there to Leonard's Mills hopefully today to take a measurement for the company that's going to manufacture that for us hopefully. And then some other various parts. Right now, we've basically gotten an estimate from Jake from Sullivan & Merritt for about $11,500 to pipe it completely. That's basically includes 2 guys for about a week, and they're just going to go over there and pipe it up if we can raise the money or figure out where the money's going to come from. We're trying to get, basically, we don't have, that price doesn't include the price of the injectors, the price of the tricocks, and the price of the sight glass. So we don't really know how much that's going to cost right now. We're thinking it's going to be not $11,000 extra dollars, but it's going to be a couple grand more anyway. So basically we're kind of unknown at that point, but we're definitely making steps in the right direction to figure out what we need. The last thing I want to talk to you guys about was we're still trying to get a hold of Jason from the Booth Bay Railroad Company. He's yet to email me back. I know that we're working with Herb. Herb's trying to email him and contact him to get a couple different people trying to get him to call us back. So hopefully he does. And when he does, he can help us sort out a few last issues we have. And then hopefully next semester we can start to pipe this thing and get it ready to go. So
I had the throttle rod and the throttle packing nut and all that. This throttle, you can't use the packing nut because the threads are messed up, and it's also cast iron, so it's not up to code for the current boiler code. Jake Olson suggested we go see Lane Manufacturing and Brewer to get that one remade. They're not, unfortunately, they're not certified. But speaking with them, though, they said if they were certified, it probably cost them about $500–700 to make just that one piece. They referred us to a company in Lincoln, Vasco. They're certified, and I'm in the works of talking to them.
So battens, we did a lot of painting and putting battens up. The reason we included this is because it consumed a lot of our time, and I feel that all of us did a pretty good job, including help from other teams. I know yesterday the drive train team did the rest of the barn doors, and so lost to us all.
So
So as far as our future plans for our next semester, we need to complete the oil system, the throttle assembly, and the exhaust plumbing, which we can do ourselves. We also need to, as Tom said, meet with state boa inspector, because we could potentially still reuse some of our old plumbing parts. And lastly, we need to hopefully get this thing plumbed up, so we're gonna run it on steam. That's it.
Good morning, everybody. We are the Cab and Woodbox team. We're going to talk to you about our progress this year and our future plans later on.
All right, some of our finds from groups that done this earlier. The doors we found fully done. Also, the fencing for the wood box was fully done. Our biggest find was the actual wood box. We were hoping we didn't have to remake that. We found that sometime late September, early October in that first Lombard shed. Also, we didn't find everything. We weren't lucky enough to find all our parts. Some, like the door handles, the door stops, and the back supports for the wood box, which were all generously made by Byron Alberry, and he did a beautiful job on all those things. After finding the parts of the wood box, we had to do a few different things to prepare them for assembly. First thing was to prepare the surfaces, initially by grinding, but then we scrubbed them down with soap water and an abrasive powder to get rid of as much of the corrosion as possible, and then we painted them. Then we prepared the geometry for assembly, first by pounding out as many of the major dents as we could, then reshaping some flanges, welding cracks, and then we did a test assembly. The picture on the bottom left is the test assembly, and we used threaded fasteners rather than the more permanent rivets that are in there right now.
Yeah, the majority of our project was getting the roof on and the fuel box. Last weekend, I worked with a guy named Darren Harvey, really skilled at restoration projects, and we used a pneumatic hammer and a machined beveled edge anvil, and we didn't have to use any heat for that to get the rivets done. And I also worked with him to manufacture the original ladder that we couldn't find. Used hand rivets and 3 carriage bolts to assemble it, and used a foot vise and acetylene oxygen torch to bend the metal. And that's us installing it right there.
One of the big things that we were able to do was, after we got the wood box assembled, was test fit it onto the machine itself. We noticed when we did that the back of the cab was actually too wide. So after we get the wood box back to Leonard's Mills and are able to fit it in the orientation that we want, we will have to cut it down so that it lays flush into the back of the cab. And on the bottom right-hand side, you can also see that the back of the cab was also too short by about 4 inches. So we have to extend that back piece just a little bit in order to get it to fit correctly. We were also able to find a few pieces in the shed. The curtain rod that we will be able to install to keep wood from falling into the cab itself. And then a few of the hinge pieces that keep the wood box extensions up when it's full of material.
Okay, so some of our goals for the future. In Bill's drawings, it showed that the back of the cabin had this nice angled woodwork all the way up the back to prevent, moisture and other outside elements from getting in. So we have to assemble that and get some tongue groove board and put that all together. We also have to mount the wood box to the Lombard itself. And as John said, that means we're going to have to reshape the back of the Lombard a little bit and make sure that everything fits properly before we do that. We're going to also have to mount the seats into the cabin so that our conductor and engineer have some place to sit when they're not filling it with water or wood. That's going to wait until the very end, so we have a lot of space inside the cabin to move around, because there'll be quite an obstruction if they're just sitting there.
We also have to put the fencing up on the sides, and we need to make sure that our braces are all the proper length. We have to make sure everything fits properly. We also need to put metal onto the roof, and we're going to need to put a moisture barrier on top of the wood before we can put the metal down, so that we don't get water seeping through the roof and causing the wood to expand and cracks and having all sorts of problems with that. Another thing we talked about was possibly making a set of stairs that could lead up into the cabin, because this is a museum piece. There's going to be kids running all around it, going up and down, so we don't want them climbing on this, two-step ladder and falling and cracking their skull open. So I think a set of stairs could be a great way to let them. Yeah.
We calculate that for the roof metal, we'll need 80 inches by 115 inches. We got a rough estimate quote of corrugated metal that's not corrugated metal coil, that's before it's gone through the corrugation, has a enamel paint, and that is roughly 3 feet wide by however long we want it cut. So it would be roughly 3 pieces at 10 feet, and it's going to be a little under 300. We also need 30 square feet of tongue and groove for the back wall. That'll be 80 feet of board at 1 inch thick by 3 inches wide. And if we can get that donated, that 80 feet is a little over, so we'll return that if not used.
Thank you very much, guys.
Sage, Kobe, Miles, Matt, Tim, and me, Cam.
Our first issue was we had no idea what we were dealing with for the front end. We heard that the skis were ripped off when they moved it first off, so we didn't know if there were skis on it, what the front end looked like at all. So we decided that first things first was let's try to get a weight on it so we can figure out and do the calculations for a temporary axle. So I got in contact with the state troopers, and they were able to come down and use their portable weights to give us a weight on each ski, and total was 4,500.
Alright, well, once we figured out this weight, we decided that we were going to build a quick temporary axle just so we get it moved from one building to the next. This temporary axle was actually donated, I believe, by Ed Berry. And we looked at it, and it's an old trailer axle, so we knew right off the bat that it wasn't going to be strong enough by itself to move this machine. So we brought it back to the machine tool lab and figured out that by adding a T-brace along the bottom, that would strengthen it along with 2 gussets at each side to provide enough strength so we can move the Lombard from the old building to the new. Basically, to put this on, all it required for us to do was just jack the front of it up, take off 4 U-bolts, and slap this axle on, basically. Well, in the process of doing this, we figured out that the U-bolts that were on there weren't exactly up to snuff because, let's face it, they're over 100 years old, and the threads were all bunged out. So we're in the process of figuring out where to get some new U-bolts and such. But basically, we got it on there and successfully moved the Lombard from the old building to the new.
So, with our temporary axle complete, we were able to successfully move the Lombard to its new home in the machinery hall, sitting right next to the cooker Lombard, which has been a huge help for us. This new building has much more room, and it's going to be a great fit for us to work and finish this project. One problem with this new building, however, was that it had no workbenches. With the help of people on the steam team and the drivetrain team, we were able to build a 24-foot long workbench along the side of the building. That's been a huge help for us. Not only has it been good for storing parts, but eventually it'll be great to put museum displays on to show off our work.
Probably one of the best contacts we've had this semester and been really helpful for us is Nick and Eric St. Cyr. They're from Damon Insulation, and when they came out to Leonard's Mill, they talked with us for a while, gave us a lot of great advice.
figure out everything we were going to need for the installation. We had a couple of selections of thicknesses for wool, or for insulation, the mineral wool that we could use. And we went out to Damon Installation, picked up a couple samples of the insulation and the metal. And you can see in the top right, we were doing just a basic compression test. And then down here, we were able to do a test around a cylinder to really see if it was going to compress down enough. And luckily, it will. So we're going to be able to get, we're using the 3-inch insulation, but Nick and Eric are going to donate all the insulation, all the metal to cover the insulation, the flat stock, the strapping, everything we need.
Alright, so we're the wheels team, obviously, so building and designing the wheels is going to be our biggest challenge. These represent our efforts to benchmark wheel design. These first two are off of another log hauler from a different company. You'll notice the spokes, they're very, very thick, and so that's what we're going to be basing our designs on. Down here in the bottom left is an antique tractor we actually found. That's more of it's not exactly a wheel, it's more a giant drum with a lot of spokes on the inside. It's not entirely unhelpful though. We can look at that for design inspiration. Also down here is one of several mock-ups we created for an axle and wheel system. You'll notice no spokes, nothing fancy. This is just an idea we had. Deciding on the details, such as like number of spokes, the designs, the thickness, all that kind of stuff. That's what we're going to be doing for a majority of the next semester.
So, back to the skis. Another small but kind of major problem we have is we're missing one of the tie rods for the skis. There's one in the front, as you can see here, and one in the back here. And what it does is it keeps the skis parallel, so they don't end up breaking if there was to be some sort of force in an opposite direction. So, from Bill's drawing right here, we need eye bolts, which can be easily purchased, but then we have this center tie rod. And we're not sure if we're going to get it machine bent yet, or if we're going to have a blacksmith, and we'll know in the near future, but it shouldn't be that bad, it should be done quickly.
The next one is the insulation. Next semester, we're hopefully going to be able to get all the insulation on using the Crooker's machine. We were able to benchmark how they did it. We've decided as a team we don't want to go up as far as they did, so that it doesn't interfere with some of the other teams' moving parts. And the one down there is the mock-up that I drew up for interferences for the insulation and the sheet metal.
So, things we have planned, we do need new U-bolts, as Colby mentioned. Brake service in Bangor, we can get them made by them for about $15 a pop, and we're going to need 4 of them to secure it. We're going to look into the ergonomics of actually steering the Lombard and how to make it a little easier, more comfortable to be up there. This other log hauler has, a little extra piece added onto the platform there for your feet to rest against. And we're also going to be looking into building a step and maybe adding handles as they did for people that are coming to visit the museum to actually be able to get up on there a little easier. The other thing we have undertaken is the bell that came on the Lombard when it arrived. We really want to see that bell put back on the Lombard. We're going to have it made by the blacksmith, so it still has an authentic look, and it'll allow the visitors to the museum to really interact with the Lombard a lot better.
This project, although challenging and oftentimes very frustrating, has been increasingly rewarding for us. And it has been a pleasure sharing this project with all of you along the way. With one very productive term under our belts, we look forward to completing this project come spring, and on main day, driving this old girl right down the mall.